Hello, everybody, and welcome to The Most Significant Bit, a podcast that explores the connection between engineering, technology, humanity, and the arts. My name is Noah, and I'm here with my co host.
Wyatt. Hello, everybody. My name is Wyatt. I'm here to be the voice of you, the viewer.
And today we're going to be discussing the Eastgate Centre and its fascinating connection with nature. Let's set the stage. Record-breaking temperatures, sweltering heat waves, and soaring AC costs. An increasing need to find ways to reduce costs on cooling is becoming a necessity. Cut to the architect at the center of our design, Mike Pierce.
Not to be confused with Mike Pence.
He's a bit of an eccentric, but always had a fascination with the magnificent designs in nature. There are two of these designs we are going to be talking about today that Mike used in his design. The first comes from the wood monsters themselves, termites.
What would termites have to do with architecture?
Well, we will find out today. Mike Pierce always had a bit of a fascination with these creatures known as termites, if you would believe.
No.
Well, he was interested in the way that they were able to keep themselves cool even during those hot summer days in Zimbabwe. Well, it turns out part of the reason that they were able to do that is because they had this wonderful design where there were chimneys that would reach up to the very tippy tops of their mounds. Basically, it would run through the entire structure that they would build up, and then they would also have holes towards the base of the structure that were closer to the ground. And when the hot air would rise and come out of the chimneys, it would leave a vacuum of air on the inside, which would pull in the colder air at the bottom of their mounds. This would basically create a continuous flow of air ventilating the structure for the termites, as well as continuously replacing the air with cooler air.
Oh, that's actually cool because the hot air down low would actually go into the thing, and then obviously it would use the fact that heat rises to actually move air physically up through the chimney per se.
Exactly. That's where it comes into the design of the building. The building is designed to have these long running chimneys running parallel to each of the building or the rooms in the building, which would connect into the ventilation system at 2 points. One at the top of the room where the hot air would go in, and then one at the bottom of the room, separate chimney that would allow the cool air to come in. The hot air would rise to the ceiling, go inside of the chimney, and go out, and the cool air from the lower parts of the building would come up and into the room. But there's a second part to this story. The termites also had another piece of their design working in their favor. They had lots and lots of these tunnels that didn't lead to anywhere all over inside their structures.
Oh, I thought the secret was the fact that they hired Frank Lloyd Wright or something cool. But I guess that works.
Not quite. They had lots of these tunnels that led to nowhere, which basically just acted as thermal mass. So during the nighttime when it was cooler, those tunnels would cool down, storing the less energy in those sections and basically being cool. And then during the daytime, those cool tunnels would release their cool air over time, consistently providing a source of cooler air. Now, Mike Pierce was smart enough to include this in the design of the building. So at the very base of the building, there's lots and lots of these running fins that are made out of concrete. What would happen is during the nighttime, due to the convection of the hot air on the inside pulling outside air in, which is cold, it would cool down all these fins, creating essentially a cool thermal mass, which could be distributed out to the rest of the building the day.
It's actually interesting. I am curious, though, with all that added material, I'd be curious if it added a lot to the construction costs. I mean, I guess over a course of time, the money you would save on air conditioning costs, because that's obviously kind of expensive, could potentially be.
And that was what we saw. There was an increased cost in the building's creation. However, we saw less than 90% of the total energy usage on cooling the building. So over time, eventually, it costs less money.
Yeah, I guess that makes sense, it makes sense, especially in an era where buildings last longer than ever. So I don't know. That's cool. I guess that's an unexpected source for the design, but that's actually pretty cool. It's very interesting.
Yeah. I'll tell you, there's one more interesting piece to this story, though, and it comes from our second source, the cactus.
Is it the same architect?
It is the same architect. Mike Pierce included this in the same design, We're talking about the Eastgate Centre here. He included a design that the cactus used in order to shed heat during the day when it would be hot outside, because they found that the termite solution wouldn't quite be enough. So the way that a cactus sheds heat during the day is by having lots and lots of surface area, lots of spines, and increasing surface area by having random jut outs.
Oh, like a heat sink.
Like a heat sink. And basically that would act as thermal, or it would act as surface area for the wind and other moving air outside of the cactus to hit the surface of the cactus and transfer out the heat. Mike Pierce designed the building so that it would have lots and lots of these little crevices all along the outside of the building that were basically acted as heat fins. They would distribute some of the heat from the building out into the outer world.
That's actually pretty interesting. And actually, even along those lines, I have, in my own time, I've read a separate article on using the design of cactuses, not for cooling, but actually for aerodynamics. Like in the American West, there's those really tall cactuses, and they have like kind of a spiral design. And right before the recession, they were planning on building a skyscraper. I think it was actually going to be one of the tallest ones in the world because, I mean, they had a lot of plans for it. But it actually utilized the structure to mitigate it because Chicago is also known as the Windy City.
Yep. And just another example of that classic biomimicry. So today we covered the special termite and cactus-inspired buildings of Eastgate in Zimbabwe. How did you think it was?
That was actually very interesting in the sense that, like, using the, I guess, the flora and fauna, technically speaking, to actually develop technology rather in the sense that it's supposed to be more in harmony with nature. It's kind of cool that they're actually taking nature as an inspiration.
Absolutely.
And in taking that, you're able to come up with higher efficiency. And then, therefore, by using less energy, you can use less fossil fuels, as well as creating a more sustainable design. So that's very interesting.
Well, thanks for listening, folks, and you all have a great day.
Adios.